Okay, here is a test problem. I wrote this myself, so if it's terrible, it's my fault. And I'm using a different pen. What do you guys think about that? Okay, so circuit has a 9-volt battery. Let's just draw this as a circuit. I'm going to draw this as a real battery, like that. So this is 9 volts, and this is R internal, and those are the endpoints. So we can model a real battery as a battery with an internal resistance. It says that right there, and it has a resistor R1 equals 17.5 ohms, and a light bulb. And the light bulb is just another resistor, but I'll draw it like this. And so here RB, I kind of like the other pin better, but I'm going to stick with this because I don't want to change. RB equals 10 ohms. And so the question is, and so I have a current like that. And so the question says also I equals 0.29 amps. And so what's the internal resistance of the battery? And if the current is constant for 4.5 hours until the battery dies, how much energy is in the battery? Okay, so let's use the loop rule. So the loop rule says that delta V equals 0. So if I start here and go around the loop, I should get to 0 volts. So if I go here, I go across this, I'm going to say IRB, that's the drop in voltage across that, negative, and then minus IR1 minus IR internal, yes, you have to include that, plus 9 equals 0. So I want to solve for that. So let's move that to I know all these values. So I can say, if I add that to both sides, to get IR internal equals 9 minus IRB plus RL, that's a L, R1. That's a bulb. That's that. So that's it. So then I divide by I get R internal is going to be 9 minus 0.29 times RB plus RI, so it's going to be 27.5. I left off the units. All of that divided by 0.029. 0.29. Okay. So let's get my calculator working. Good. Drop. So I get 9 enter 0.29 enter 27.5 times minus, and then good thing I didn't get a negative current, minus that, and then divide by 0.29 divided by, and I get 3.53 Ri equals 3.53 ohms. That's the internal resistance of the battery. So when you're working on these problems, it's important to say things like this. Don't just start writing down equations like that, because where does it come from? It's important that you explain where everything's coming from. Okay, now how about this? Okay, so the battery dies, so I can first calculate the power through the battery. So power is I delta V. And so that's going to be equal to 0.29 amps times 9 volts. So the power from the battery is going to be that. And power is also change in energy over the change in time. So if I multiply both sides by delta T, I can get the energy. So delta E equals P delta T. So it's going to be 0.29 times 9 times the time. Now, the time is going to be equal to, let me write it up here, delta T equals 4.5 hours. But this power is in watts, which is a joule per second. So I need to multiply that by 60 minutes per 1 hour. I don't like this pen. And 60 seconds per minute. So if I multiply this by 3600, I get the time. So this is going to be 4.5 times 3600. So if I put all that in, let's do that. So I get 0.29 times 4.5 times 3600 times. And I get 42282 joules. the end.